multilaterals. You can read on through the list: subsea wells, separation technology, metering, multi-phase pumping, high-strength steels, and automated welding, and long-distance multi-phase flow modeling and capability. They're all there. And again, the idea here is, to the extent your technology can help bring costs down in those areas, there'll be direct benefit, and again, a leverage benefit when you move that up into the remote regions. Some of the ones that are evolving, not so much in the south, but we're putting dual activity rigs in remote regions, and of course drilling has become faster. Slim hole drilling, if you move less material, less manpower, less fuel, less mud, it brings costs down. It's so there's an area of evolution of slim hole tools, multilateral, smart well. Again, you can read the list. Subsea processing, compression, and power transmission is seeing some technological evolution driven by the offshore industry. Subsea to beach, eliminate the offshore structure. High fraction multi-phase metering, and wireless. Just had a talk on wireless. Huge opportunity if we can avoid the hookup, commission things, modules before we take them up, and avoid all the hookup issues when you're in that Arctic environment. It's very important. So what are the key challenges? I boil it down to two things. There are two showstoppers when it comes to Arctic development in Canada. One is high cost, and the other is getting regulatory approvals. And high cost, it's both drilling and development costs. The regulatory approval issues, if anybody's kept track of the Mackenzie Gas Project, and they're around about 4 years we've been at it, we're world class in an area that we want to improve in there. But getting approval, you can get stopped 100 ways, and focusing your technology on anticipating issues and bringing that technology to bear to understand them better is very important for us, and it's a key area of our forward planning for Arctic projects. This chart just talks about, again, in the offshore, just some of the key areas that we focus on an ongoing basis. Ice load prediction, ice scour, the ice I showed you earlier. Subsea offshore drilling, tankering, safety and logistics, extended ultra-reach drilling. Again, you can read the list. Emergency response, e-field, e-drilling, e-projects, e-field is a focus area for technology. Again, wireless, things like that. Using the communications technology we have to use less people. If we can keep people in the south and they can monitor what's going on in the north, it's a win-win all around. You get better data and you get better control. And of course, oil spill technology is an ongoing area of research. So final slide, future collaboration areas, remote sensing and communication. Certainly there's much more that can be done. We're just begun to utilize some of the tools that are already on the shelf, and there's huge opportunity there going forward to improve how we do business. Provide physical and biological information that'll facilitate regulatory assessment, address regulatory challenges, and so on. Again, a huge area. These are all areas in the south. To the extent the technologies can help us be more efficient in how we execute them in the future in the north, will add significant value. Addressing the access window and schedule, the 3-month seasons we have is significant. Again, it all comes down to efficiency. Stakeholder expectations, if we can address them in advance, as mentioned. And of course, oil spill is an ongoing area there. So really, I'll summarize here. There's some elements of the north that are very unique in the environment, physical environment, but the underlying technology to produce oil and gas is very much the same. So if you have a better mousetrap for a technology that's useful in Alberta, it could have even more value for us in the north, and that's the general some words of wisdom and observations. We have some northern specific factors, issues, things like ice, and it's ice you'd think would be something that's well known, but it's very difficult to measure the properties of ice and their scaling effects. There may be possibilities for nanotechnology in worlds like that. If you could embed little tattletale sensors in ice and then test it, you'd be able to tell what's going on the inside. And wouldn't that be a different perspective than trying to crush it like a concrete test sample? So those are just some observations. Again, I apologize. I meant to generate some slides that are perhaps more specific to Western Canada, but I'll just mention a couple of things verbally that you might find interesting. Some observations about opportunity areas. One thing I haven't seen here so far is corrosion. the possibilities for using MNT type technology to investigate corrosion. When you think about the infrastructure we have in the province of Alberta and globally, it's aging, and as things age, velocities drop. You develop new corrosion issues that you didn't have before because that are velocity related. You can't distribute the corrosion inhibitors and so on. So just the possibility, I just submit this for your consideration, the possibility of being able to embed sensors in a corrosion cell, tell if it's active or not, possibly to neutralize it. There's a story I can't repeat here, but I've seen circumstances where we had to make decisions on where corrosion was going to go with specific pieces of equipment that were very important in terms of whether we shut down immediately or went on. And there I see potential here in this world for perhaps going into that area. Waste management, anything you can do for water and air emission, water purification, air emissions, obviously bread and butter. They're global, they're everywhere. Western Canada, they're in the north. Reducing oil content in released water. Some of the talks earlier today, rejecting CO2 at high pressure. All of our sweetening processes reject CO2 using heat and low pressure. There's a talk earlier today I found very interesting. We're going to follow up on it. It's a golden key, absorbing CO2 in lower concentrations, geomatics. Again, so a lot of opportunity areas here, and those are just a few perspectives. So that's basically, I'll close with that. Do you have any questions?